Solve for particular solution. X plus y dy plus x minus y dx is equals to 0, y is equals to 1 and x is equals to 1. So answer dy by dx is equals to minus x minus y upon x plus y is equals to f of xy. We can clearly see that this is a homogeneous equation. Now to solve, simply substitute y is equals to vx, differentiating both the sets with respect to x, dy upon dx is equals to vx dv by dx. Substituting this value in equation 1, we will get v plus h dv by dx is equals to v minus 1 upon v plus 1. H dv by dx is equals to minus 1 plus v square upon 1 plus v. We just put this v on the right hand side and then cross multiply. So 1 plus v upon 1 plus v square dv is equals to v upon 1 plus v square. We'll just give separate denominators to the numerator. So v upon 1 plus v square plus 1 upon 1 plus v square dv is equals to minus dx upon. Integrating both the sets, we'll get log 1 plus v square plus tan inverse of v is equals to minus log x plus k. So half will also be there. So then we'll put this half to the right hand side. So log 1 plus v square plus 2 tan inverse of v is equals to, so we'll basically multiply this whole equation by 2 is equals to minus 2 log x plus 2k. So log 1 plus y by x the whole square into x square is equal plus 2 tan inverse of y by x is equals to 2k. So log x square plus y square plus 2 tan inverse of y upon x is equals to 2k. Now putting y is equals to 1 and x is equals to 1, log 2 plus 2 tan inverse of 1 is equals to 2k. So tan inverse of 1 is pi by 2, so pi by 2 plus log 2 is equals to 2k. After substituting the values of 2k in the equation, log x square plus y square plus 2 tan inverse of y by x is equals to pi by 2 plus log 2. This is the required solution.